Let's give the number of ways we can arrange the letters in the word Mississippi. So we're looking for unique arrangements here. Let's think about why we need to think about this in the first place. If I write MISSISSIPPI, then you would have no idea that I switched these two P's around. Right? I didn't get a unique word. So we're going to count the number of arrangements we can make from the word Mississippi that give us a unique arrangement. So we can't tell the difference between repeating characters. Let's count how many characters we have in general. How many letters are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So when we make our arrangement, there's 11 factorial total ways to arrange the letters in the word Mississippi. But we can't tell the difference between some of those arrangements, right? Here's 2 unique arrangements, but they don't look unique. So we need to ignore or divide by the number of ways to arrange the repeating characters. So let's think about the M. The M is only present once. Let's think about the I. I've got one there, one there, one there, and one there. So I have 4 I's, which means that those 4 I's can be arranged differently, and I wouldn't be able to tell the difference. And how many ways are there to arrange 4 I's? 4 factorial. So we need to ignore the 4 factorial arrangements that confuse the order of the I's. What else do we need to ignore? I see repeating S's. In fact, we have 4 of those. 4 factorial of the 11 factorial arrangements confuse the position of those S's, and we can't tell the difference. So it does not give us a unique arrangement. What else do we need to ignore? We've talked about the M, the I, the S's, and these 2 P's. So if we switch those 2 P's around, we wouldn't be able to tell. And there are 2 factorial arrangements that give those two P's in 2 different places. In fact, 2 factorial is just equal to 2 times 1, so 2. In fact, these are the 2 different arrangements of those P's. You just switch the P's. Okay, when you go through this, let's work on some algebra. I know that inside of 11 factorial is a 4 factorial. So I can write this as 11 times 10, 9, 8, 7, 6, 5. And then the 4 factorial will be replaced. I have 4, 3, 2, 1 from that 4 factorial, and then a 2 factorial. Let's see, what can we do? We don't need to worry about multiplication by ones. That's the multiplicative identity. I can take that 4 from that 8, and I'm left with 11, 10, 9, 7, 6, 5. Oh, sorry. If you take 8 divided by 4 gives you 2 on top. We've still got the 3 times the 2 times the 2. Let's see, that 10 divides that 2, or rather the 2 divides the 10, you get 11, 5, 9. In fact, let's take a 3 away from that 9. You're left with a 3. So 11, the 10 turned into a 5, the 9 turned into a 3. We're left with, in fact, 2 and 2. We're only left with the 7, the 6, the 5. And this is going to give us 34,650. So a lot of different arrangements there.